Hi friends, this is Arpit Chauhan here, and today we are going to discuss about important topics that comes in exam, and that is a part of engineering mathematics too. So today we'll discuss about Fourier analysis. So I have divided this whole unit in four sections, and we will discuss on each topic one by one. So today we are going to start with the Fourier series. Okay, so what is this Fourier series? Okay, so as we have discussed in earlier mathematics, that is M1, we came to know that we can define any function in terms of algebraic series. So we have to define those functions in algebraic series. We have to use the Maclaurin's or Taylor series, right? Likewise, uh, if we want to represent uh, our function in terms of sine and cos, then the series which we'll be going to use is a Fourier series. So in order to represent a function in terms of sine and cos, we have to use a Fourier series. Okay, so before we proceed further, in order to understand the Fourier series, we have to know some basics which will be going to use in order to solve the Fourier series. So what are those basics? Let's understand those basics. So first of all, we should know about periodic function. So what is this periodic function? Periodic function is a function that represent periodic function is a function that repeat its value in regular interval of time. Okay, I repeat, periodic function is a function that repeat its values after particular interval of time or after regular interval of time or period, then that function is known as periodic function. Okay, let's take the example of periodic function. Let me define the periodic function is define the periodic function for you. Periodic function is a function that repeat its values after regular interval of time or period. Okay, now let's take the example. Suppose if we have given the function x, and which is periodically defined in the interval minus pi to pi. Okay, so if we will plot the graph for this function, what we'll get? We'll get the graph like this. This is 0, this is pi, this is 2 pi, and continuously 3 pi, and so on. And here minus pi, minus 2 pi, and here it is minus 3 pi. And if you want to plot the graph for this, we'll get the graph like this, right? So what the periodic function says, like periodic function is a function that repeat its values after regular interval of time. So after pi to 2 pi, it will repeat its interval. Likewise 2 pi to 3 pi, and so on. Okay, so this is periodic function. Now you might be thinking that I have defined the function x, which is not periodic, since it should be a straight line, right? So it cannot be periodic, but we can make any function as a periodic function. We can make any function as a periodic function. Suppose if I will add in this 2 pi, then after this interval 2 pi, this function will repeating its value. So this function will be periodic after 2 pi. So we can make any function a periodic function, and it's up to us, like in how much interval of time we are going to making the function as a periodic function. So in the same way, as you know that in trigonometry there are the function which are periodic function, like sine 2 pi, cos 2 pi, tan 2 pi. These are the periodic function. Why? Because these functions repeat its value after this interval of times. That's why these are the periodic function. Now, in order to solve the Fourier series, we should know some definite integral properties. So here now I'm going to discuss about some definite integral properties. uh, First property is integral minus a to a fx dx is equals to twice of 0 to a fx dx if the given function is even function, and the value of minus a to a fx dx will be 0 if the given function is odd function. Okay, so how you will identify that the given function is even or odd? So in order to identify the function is even function or odd function, we should know about even function. What is even function? So what is even function? The definition of even function is a function is said to be even function. A function is said to be even function if and only if f of minus x is equal to fx. It means that suppose we have given any function like x square, okay, and in this if we are changing the value as minus of x, so here minus of x is square. Now after solving this we are getting the same value, right? That is x square. So this function is said to be even function. This means that if we are changing the sign of the given variable from plus x to minus x, and when after solving the function we are getting the same function, and that function is said to be even function. Same wise, cos of minus x is equal to cos x, so this cos x is also a even function. Now what is odd function? A function is said to be odd function if and only if f of minus x is equal to minus of fx. F of minus x is equal to minus of fx. Example, fx equal to x cube. So when we are putting the value as minus x, then minus x cube will get the value minus of x, right? So when we are changing the sign of a variable, we are getting the opposite value, then that function is known as odd function. Likewise, sine of minus x is equal to minus of sine x. So this function is said to be an odd function. Okay students, this is all about the basics of integrals, and that is that and these functions will be useful in Fourier series. While solving the Fourier series, we will be going to use this function and this integral property. So that's all about today's lecture, and from the next session we'll discuss about Fourier series and we'll solve some problems on Fourier series. Okay students, so if you like the video, then please do subscribe my channel and like and do share the videos with your friends. Thank you, thanks for watching the video. Bye bye.